All right, so let's look at the homework. So use the tables of ordered pairs to determine the value of each composition function. All right, so what am I looking at? Here we have a table. So f of x is equal to x squared minus 15. And when x is a particular value, it tells us the value of the function, the y basically, the value of the function f of x. So when x is 1, f of x is negative 14. When x is 2, f of x is negative 11, so on and so forth. All right, we also have a second table. G of x is equal to the square root of x. So a completely different function. So when x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. And the list goes on. Right, the list goes on. So we're going to use these tables to solve the composition of functions. The composition, right? I'm composing one function with another function. So essentially what's happening is that I'm taking an x value, a particular x value, and I'm taking that value and I'm plugging it in to g. That's going to give me a value. Then I'm going to plug whatever that is into f. And then eventually, the way this works is, right, this is f of g of x, f of g of 36, basically. So since 36 is my x, I'm going to plug that into g. So what this is saying is that take x is equal to 36 and plug it into g, right? G of x says that when x is 36, the whole thing is 6. So when I take 36 and I plug it into g, I get 6. Now I'm going to take that 6 and plug it into f. So when f is 6, the value is actually 21. So let's see if I can recap and make this kind of better. So what's happening? All right. We have, come on, bro. G of 36, right? That's going to give us something. And I'm going to plug that into f. That's basically what's happening, right? So that means G of 36, we said that this was really 6. So f of 6. So take 6 and plug it into f, and we get 21. That's basically the deal. So let's try it again. So now, again, this is my x. Right? You always start with that most right value. That's your x. And then you just work your way left. So when x is 16, I'm going to plug that into g. All right, this is saying, right, so here we have when x is 16. When x is 16, I plug into g, we get 4. So 4 is my new x value. I got to take 4 and plug it into g again. So when x is 4, y is 2. So the answer is 2. Hopefully you can see the pattern here. It's all based on what this x is to the right, and whatever is to its immediate left, that's the function we go to figure out what the new output is. And then that output is the new input into the next function. Right? It's just like kicking the can down the street, right? You just keep moving it right along. So here we have, I'll switch colors. So the first x value we have, or the next x value we have, is 4. So right now, x is 4. I have to take x, and this time we're going to plug it into f. So when x is 4, my output is 1. So 1 is my new x value that I'm going to take and put into G. So when x is 1, oh look, y is 1. So 1. All right, last one. Let's do blue. So when x is 4, right, that's my x. That's my input. Where am I plugging it? I'm plugging it into F. So under the F table, when x is 4, y is going to be 1. The output is 1. So 1 is my new x value. So I'm plugging that into F again. The output's negative 14. All right, you might have to go back and watch that a couple times before you can, I guess, finally get the hang of it. All right. So that's when we have tables to look at. All right. Say we don't have a table. Say if we have a graph, it's just as good as a table. So we have 3 graphs here. In red, we have h of x. In green, we have g of x. In blue, we have f of x. All right. So remember, the x value is to the right. So this is saying let x equal 3. So I want to look, when x is 3, what is the y value in the f graph? So here, when x is 3, so here's 3. The y value for the f graph is 4. So 4, that's the output, which is the new input into what? H. So I want to plug x equals h, or x equals 4 into h. Or technically negative 4. My bad, it's negative 4 because it's below the x-axis. It's negative 4. So I take negative 4 and plug that into h. And I see that the new output is positive 5. All right, let's reset. We have x equals 4. Positive 4. So when x is positive 4, we want to look at the g graph. So when x is equal to 4, so x-axis is 4, so right here. In the g graph, g of x, 2. That's my new x. So I want to see when x equals 2, but this time for f. So when x is equal to 2, we're going to get negative 3 on the blue graph. The y value is negative 3. Right, the y value, the value of the function, f of x, they all mean the same thing. Right, the output basically. All right, next. Erase this. So x is negative 4. So when x is negative 4, we're looking at f. We're going to grab a y value, that's going to be the new x value, and then we're going to plug it back into f. So when x is -4, in the blue graph, we have y is equal to -5. So -5 is the new input into f again. So -5, the y value is going to be -6. So -6. All right, hopefully we can all see where this is going. Now we have x is equal to 1. So when x is equal to 1, I'm looking at the y value for g. So at x equals 1, the y value for g is going to be 0. It's going to be 0. So that's my new x input for g again. So when x is 0, g is going to be +2. +2. All right, last but not least, when x is 0, we're looking at h. When x is 0, we're looking at h. So when x is 0, h is +5. So +5, that's now going to go into g, because we went to h and now we go to g. So +5, when x is +5, in g, the y is 0. So when you're working on the composition of functions composed like this, right, you always start with the most right number, right? That's your input. And then you work your way left in order. All right. All right, number 3. Sally, salesperson, sells shoes part-time at Super Shoes in the South Street Mall. She earns 2% commission on total sales over $5,000, which is paid as a bonus at the end of the year. Let her total sales be represented by X. So X represents total sales. All right. F of X is equal to X minus 5,000. G of X is equal to 0.02X. Which composition of functions would calculate her bonus at the end of the year? F of G of X or G of F of X? Explain your reasoning. All right. So let's think about this for a second. This chick sells shoes and she earns 2% commission on total sales over $5,000. So if she made $4,999, which is obviously less than $5,000, she ain't getting anything, right? She don't get no kind of sales bonus because she only gets a bonus on sales that are over $5,000. So let's just assume for a second that she made $5,001, right? Something bigger than 5,000. If she made something bigger than 5,000, that means X, right? 5,001, right? Because that's bigger than 5,000. She'll earn 2% commission on $1. So on total sales over 5,000, right? Which is paid at the end of the year. Okay. So if X is 5,001, right? Because that's how that would be her total sales. So when we start plugging X in, right, that would be plug it in here, plug it in here. So let's look at F of G of X first. So that means X is 5,001. So doing what we just did in the above problem, I'm going to plug it into G first. So 5,001 times 0.02. Here, look, so it looks correct. Times 0.02. So that's going to be 2, 0, 0, 10, 2 decimal places. So my new x is 102. If I plug that into f, because that's what it's saying to compose it, so now I'm taking $100.02 and plugging it in, and this is going to be, so now we're doing f of x, right? So this is going to be 102 or $100.02 minus 5,000. And that's 4,900, 4,900, 4,899.98. No, 800.98. Right, because 2 cents would turn that to 900, then 100. Yep. So that don't even make sense, to be quite honest. I mean, in more ways than one. So if you're just learning this, you're like, what the heck's going on right now? So we're applying this idea of a composition of functions into an actual practical problem. And the first thing that we're looking at is f of g of x. So if the total sales is 5,001, when you plug it into the composition, appropriately, we get $4,899.98. And that, honestly, it doesn't make sense. It doesn't make sense because that's supposed to be the money that she's getting, right? She's supposed to get a bonus. That doesn't even sound right. So let's try the other one. F of g of x. So here, let's just put that on the back burner. I'll write that off to the side. 4,899.98. All right. So again, same problem, but this time it's f of g of x. So I'm going to take x and I'm going to plug it into f first, and then I'm going to take whatever comes out and plug that into g. So I'm taking, again, we're letting x equal 5,001. Plug it into f, so 5,001 minus 5,000. As a matter of fact, just backtracking for a second, $100 minus 5,000, that gives us negative. That gives us negative. A negative 4,899.98. So already that for sure doesn't make sense now because it's negative. So how am I supposed to get a bonus if it's negative? So I think that one's the incorrect one. So g of f of x, the one we're working on now, the second one, when x is 5,001 or larger than 5,000, right? We're going to get positive 1. That's my new input. If I plug that into g of x, that's going to be 1 times 0.02, which is equal to 0.02, which is 2 cents. So that actually makes more sense because think about it, right? If she sold 5,001, she's getting a 2% commission on sales over $5,000. Well, since we let x equal 5,001, she sold $1 more, $1 over 5,000. So what's 2% of $1? Well, 2 cents. So I think the explanation here is obviously the second one, because like it fits the model, right? Like it fits the problem. The second one fits the problem. The first one did not, because calculating it the way that we did, we came out with negative, like a negative amount, and that just doesn't make sense. So I think it's the second one, f of g of x. I would bet money on this one. So anything over 5,000, she's getting a 2% commission. So we need to figure out, okay, well, how much over 2,000 are we? So then the first part, the f of x part, that makes sense, right? Because if x is larger than 5,000 and then you take away 5,000, that's the leftover part. That's the part that you're going to get the commission on, the 2% of whatever that number is. So, all right. All right, let's look at the back. Or not the back, but the next page. Okay. F of g of 3. So we have up top 4 functions, f, g, h, and j. This is telling us to take 3 and plug it into g. All right, bet, let's do that. So g of x is 3x minus 2. All right, g of x is 3x minus 2. So when I plug in 3, I'm getting, so g of 3 is going to be 3 times 3 minus 2. So 3 times 3 is 9. 9 minus 2 is 7. So 7 is my new input. Where am I putting 7? I'm putting it into f. F, in this case, f of x is equal to 2x squared. So that means f of 7 to 7 squared. So 7 squared is 49. 49 times 2, 98. So the answer, final answer, is 98. Okay. I know that went quick, but, you know, it is what it is, right? That's how it goes. So x is 12. I'm putting it into j. So what's j? J of x is equal to 6 over x. Okay. So I'm putting 12 into j. So that means 6 over 12, which reduces to 1 over 2. So 1/2 is the new input. Where am I putting that? I'm putting that into h. H of x is 3 minus 4x. So when I take 12, not 12, 1/2, I take 1/2, I plug it into h, and I get 3 minus 4 times 1/2, which is, so 4 times 1/2 is 2. 3 minus 2 is 1. Let's go. Oh, you can't see it. There it is. Okay. All right, so now g of h. So we don't have a number. We don't have a number. We just have x. So that's fine. So h of x is equal to 3 minus 4x. When I plug x in, okay, I get 3 minus 4x. So here's where it's going to get kind of uncomfortable. So my new input is going to be 3 minus 4x. That's what I'm plugging into g. So g, in this case, g of x is equal to 3 x minus 2. So now I'm taking 3 minus 4x and I'm plugging that into x. Well, technically I'm plugging that into g and then substituting it into x. So g of 3 minus 4x is equal to 3. Right, wherever there's an x, I'm putting 3 minus 4x because that's the input. The input isn't just a number, it's an algebraic expression right now. Okay, minus 2. So then simplifying, we're going to get, I'm going to distribute. So right now we're at the answer, just FYI. We're at the answer, but we're going to clean it up. 3 times 3 is 9. Minus 3 times 4 is 12x. Minus 2. Combining like terms, we get 9 minus 2, which is 7, minus 12x. All right, this is the final answer. I might have to go back and watch that a couple times to grasp that, right? X is x. We take x, we plug it into h, just the same way we did in the previous two examples. The only difference is the output isn't a number, right? Because x isn't a number, it's a variable. So the output was 3 minus 4x. So that's our input into G. That's what we're plugging in to here. And then that's what we did. We plugged it in. You see it right there. And then wherever there's an x, the input shows up. We distribute, combine like terms, arrive at the answer. Okay, last example. We're taking x, we're plugging it into G. So when I do that, we're getting G of x is equal to 3x minus 2. All right, that's my input. That's my input that's going to go into H. So H says 3 minus 4x. Okay? I'm taking my input, plugging it in to, or taking the output and making it the input, right? Because it's going into H of x. So this is H. 3x minus 2 is equal to 3 minus 4, 3x minus 2. All right, we're at the answer. That's it. However, let's clean it up, right? You always want to distribute as much as possible. Expand this out. So when I distribute negative 4, we're getting 3 minus, so negative 4 times 3 is 12x, right? Minus 12x. Negative 4 times negative 2 is positive 8. And we are combining like terms. So 8, 9, 10, 11 minus 12x. And that is the final answer.